Okay, Trig, we are on to the back half of the review. We should have done the first half yesterday. If you do not have that, go to Google Classroom and get that video watched, but we'll do the second half today. I still do not have my smart calculator, so I'm going to walk you through the steps for number 33, but tomorrow when I come back, we'll probably go through, or I'll do it on the calculator just to make sure I get the same thing as what you get. So try that one on your own. Tate, if you're looking for a calculator, I did see on my bookshelf back where like the whiteboards are, there's my pink calculator. It's mine. You can have it, but you can practice with it for now and maybe use it for the test if you can't find yours. It's a nice one and it's my pink fancy one, so you can use that one for now. So let's just start from the top. And 19 and 20 are putting stuff together. So we're expressing as a single log, and then 21 and 22 we're tearing it apart. So we're expanding. So condensing versus expanding, that's what we're doing on the next 4 problems. So if you want to, actually I would encourage it, pause the video, try 19 and 20 by yourself, and there you go. Okay, 19. We've got 3 pieces, 1, 2, 3, and we're trying to condense them together. They are LNs. They're all 3 LNs. If they were not the same log, we could not put them together, but since they are, we can. And our final answer is going to be LN of a bunch of junk, right? We're going to put everything together, okay? The first thing that I want to do when I'm putting stuff together is make sure that if I have any numbers in front of my LNs, this one does, I have to put it to the back. So this becomes x to the 3rd power. And I get rid of him in the front, okay? These 2 didn't have one, so we're good to go. Now, plus means multiply, and so what I'm going to do is I'm going to multiply 3x and 3y together, which is 9xy, and then minus means that thing is going to go to the bottom, so x to the 3rd power goes on the bottom. Ooh, they tried to trick you. I can cancel this x with one of these. So final answer, ln, that was tricky, 9y over x squared. That's completely simplified. Okay? Completely simplified. There he is. Okay? The next one, another condensed one. Oh, what? All right, you might have tried to condense this one, but I'm going to do one thing really quick first. Let's do this. We're going to end up with something funny. There are 2 pieces right here. That's kind of weird. Okay, so before we condense, I know it says that we're supposed to condense, but let's expand this guy really quick first, okay? So what I'm going to do here is I'm going to say ln of e squared plus ln of x, because that's what these 2 are. They're multiplied together, and multiply means add. So I'm separating them into 2 pieces, and that becomes that. Okay, same thing here. If I separate this into 2 pieces, plus is just going to fall down from there, okay? This would be ln of e plus ln y, yeah? And then I've got minus 3. Okay, so I know it says we're supposed to condense, but just hear me out for a second. All right, ln and e cancel with each other, and what that's going to do is this 2 is going to come down in front, so I have 2 plus ln x is just going to stay ln x, okay? This ln and e cancels, but don't just cancel it out and make it 0. It cancels out and it becomes 1, and then I've got ln y minus 3. Okay, 2 plus 1 minus 3. All of that cancels. Now I just have ln of x plus ln of y. Now I'm going to condense. Okay, so I've got 1 ln and all of it put together. Plus is between ln and x and y. So plus means multiply, and that's what it's going to look like. Okay, so you might have tried to condense that and left the e's in there, but like I just have like bells dinging in my head whenever I see ln and e, and I'm like, can I do something? I can only cancel ln and e if these 2 are separated from each other, or if these 2 are separated from each other. So I'm going to break them apart first, cancel the ln and e, which is kind of fancy, and then we put everything back together again. Okay, so kind of went against what we were supposed to do, but it all worked out in the end because it made it really nice. Okay, all right, expand. Okay, all right. We've got a bunch of different things going on here. Let's figure out when I look at logs that I'm trying to expand, I look at stuff in parentheses and I say, okay, like how many pieces am I going to end up with, right? Like I have an x squared on the top, that's 1 piece. I have a y cubed on the bottom, that's another piece. But like down below here, do I have like 4 pieces? No, z plus 1 is one piece. That's going to go together because those two are trapped. So I'm only going to have 3 pieces when I am finished, okay? And I'm going to have log base 3. So I'm going to start with this. Ooh. Log base 3 of x squared is going to be one of them. And because x squared and y cubed are multiplied, that means add. So I've got add log base 3 of y cubed. That's what he looks like. Z plus 1 is on the bottom, so I'm going to do minus log base 3 of, and I'm going to do z plus 1 in parentheses. Okay, if I don't do parentheses, look what happens. Z plus 1. It looks like this, and then plus 1 on the end. So please put parentheses around your z plus 1. Okay, one more thing that we can do. It's like up here, like my very first step to put stuff together. I move the stuff to the back. That's my very last step when I'm condensing or expanding, is to move these guys down in front. Okay, so this guy becomes a 3. The 2 goes here. This one doesn't have 1 because he's just a 1 right here. So I'm going to rewrite him. Nice. 2 log base 3 of x. When you're writing these out, it's kind of a pet peeve of mine. Make sure that the 2 and the log are on the same level. Same thing with the x, and the 3 is kind of down lower. Okay, sometimes people like try to put their x like floating all the way up and it looks like an exponent and it drives me crazy. Okay, so 2 and log and x should all be on the same level. All right, plus 3 log 3 of y. Ooh, does 3 and log 3 cancel? Does this cancel? It would cancel if it was log base 3 of 3. That would cancel, but not if the 3 is in the front, okay? I know that was running through some of you guys' heads. And then z plus 1, and there we go, and that is completely expanded, okay? If you want to check your answer, you can condense it. It should come out to look like this, but we're not going to do that right now, okay? 22. Are you trying these on your own? Are you trying these on your own first? This one's a tough one. I've got one piece here, e to the 4th, and then I've got my bottom has actually 2 pieces. 2 pieces. Okay. Real quick, when I have 2 pieces underneath of a square root, I'm going to write this. I'm going to write it like this. Whoop. That's my children. Get ready for bed alarm. E to the 4th power. I'm going to write it as the square root of x and the square root of y instead of the square root of xy. So now I have them 2 separate pieces. So I've got my 3 pieces. 1, 2, 3, and I can just like do all that stuff and break them apart. Okay. All right. So first is going to be ln of e to the 4th power. Again, ln and e are going to cancel, but we'll do that here in a second. The bottom, since I'm, oop, gosh dang it, and now I moved it. Okay. Okay. We're back. Maybe. These 2 are both on the bottom, so we have to do minus for both of them. I'm going to put those minuses there so I don't forget it. I've got ln of the square root of x, and then another minus ln the square root of y. Okay? Some of you guys like to do it this way, where you do parentheses and you do a plus, and that's totally fine. Because this plus sign is saying this is being multiplied by that, but then it's divided by that. So if you want to do that, I don't care. Some people like to do minus minus. Whichever one is your go-to, you just do you, okay? This square root is x to the 1/2 power, and this is y to the 1/2 power. So I've got to take this 1/2, move it down in front, 1/2, move it down in front, okay? It's got to go in front of both the x and the y in order for that to work. Gosh dang it, I keep hitting something. In order for that to reflect that they're both underneath of the square root. If you would only put the 1/2 to the x power, it would look like the y was not underneath, and that's not true, okay? All right, let's cancel some stuff. So ln and e cancel. This is 4 minus 1/2 ln x minus 1/2 ln y. Now, you could do 4 minus 1/2, and then you could do ln x plus ln y. That's the same thing, right? Like this times this, and then it's all underneath of the square root if you move the whole thing to the back. Whatever. This means the same thing as this, and I don't care which one you use. Okay, they are technically both completely expanded, just using parentheses and not using parentheses. I don't care. I will take either answer. Okay, so that was expanding, all right? Now we're going to be solving some stuff, like the next 8 problems, all right? And these ones, you guys, I feel like you guys are pretty crisp on these. Like, you do a decent job at this, all right? Some of these are kind of tricky. So go ahead and let's just, like, try, I don't know if you want to do this piece by piece, but, like, try to do, like, 23 and 24. And then unpause, okay? So if you're pausing, do 23, 24, and then here you go. All right. Okay, starting with 23. I cannot cancel two logs if they're on the same side of the equal sign, but what I can do is minus means divide. So I have log base 2 of the things that I'm dividing is this guy divided by this guy. So I've got x minus 3 over 4, and that's equal to 3. Okay, now I look for any algebra stuff that I can do. Is there anything, like, can I multiply this 4 over to the other side? Not if it's trapped inside of the log. That's not going to work. So I am at a dead end. And when you're at a dead end, you switch it to the other form. He is in log form. I'm going to make him an exponential form. So he is now 2. Gosh, dang it. I'm having all sorts of technical difficulties. Here we go. He is 2 to the third power equals x minus 3 over 4. Okay? In place of 2 to the third power, I'm just going to write 8 because that's what 2 to the third power is. And now I just do the algebra stuff. All my logs are gone. All my exponential really is gone because I cubed it out. And now I'm going to multiply by 4. So 8 times 4 is 32 equals x minus 3. And then I'm going to add the 3 over. Okay. X equals 35. I think. Yep, 35. Good. That was 23. Okay, 24. I have two ln's on the same side again, and plus means multiply. So what are you multiplying? This guy by 5. So what I'm going to do is I'm going to distribute the 5 through. I don't know if I'm supposed to, but I'm going to. Okay, like, or if I should leave them separate. We'll just distribute them through. 5x plus 20. Yeah, I think we're not going to run into problems if we do that. Okay. This is going to be a decimal answer, by the way. That is totally legal. Like, we're big kids now. Not everything is going to come out as a nice answer. So here's the deal. I'm at a dead end. I can't do any more algebra. So I have to switch this to an exponential function. All right. Now, when I'm switching ln to an exponential function, I have to kind of like keep in mind that this is actually log base e. Okay. So you might want to do the rewrite step first. Like, rewrite ln as log e. Now I can say e to the second power equals 5x plus 20. Okay. All right. E to the second power is like, I don't know, 5 point something. I have no idea. E to the, no. E to the second power. Nope, I was wrong. 7.389, something like that. Okay. Plus 20. Okay. Now I'm going to subtract the 20. Minus 20, and then I'm going to divide by 5 as well at the same time, right? So minus 20 divided by 5. So finally my x is negative 12.61. Okay, now some of you guys might be already checking this because anytime I get a negative number, I'm like, are you sure? If you leave it as negative 12.61, I will not hold it against you. But technically, if you plug negative 12.61 in right here, this will give you a negative 8.61, right? Can you take an ln or a log of a negative 8.61? No, you cannot. So technically, this one has no solutions because that one is not a solution. If you leave it negative 12.61, I probably won't hold it against you. But just be aware of that. That might be a thing. Okay? I don't know if I try to trick you like that on the test. But there's that. Okay? All right. If you're pausing, pause for 25 and 26. Do that now. Go. 25. We have 3 logs, but I can't just cancel. I can only cancel 1 log for 1 log, which means these two have to go together. And plus is between them, and plus means multiply. So log base 3 of, I'm going to take 6 times x minus 3, so I'm going to distribute it, 6x minus 18. And I've got equals log base 3 of 4x minus 8. And log base 3 is on both sides, so I can just cancel those, and that's kind of nice. So I have 4x minus 8 equals 6x minus 18, and I just did the math. Okay, I'm going to subtract 4x. That goes away, and then I'm going to add the 18 at the same time. So hopefully that wasn't too messy. This is 10 equals 2x, and x equals 5. Cool. Very good. Okay, 26. Oh, this was kind of messy. A little bit. All right, I've got 2 ln's, and I can't just cancel them like this, right, and make this 2x, because the 2 is like in front here. But what I can do is I can move them to the back. So I've got ln x squared equals ln 25. Yeah? Now I can cancel my ln's. Hey, that's nice. X squared equals 25, and then we take the square root. Now, x equals, the square root of 25 is plus minus 5. But, if I plug 5 in here and take ln of 5, that's totally legit. But ln of negative 5, we can't take logs of negative numbers. So really, the only answer is x equals 5, because negative 5 is an extra answer. I probably won't hold it against you if you put negative 5 as well, but just try to make me happy and plug the numbers back in, okay? All right. 27 and 28. I'll give you a little hint. You are trying to get these two numbers to be the same base number. And you can in both of them. So 27, 28, try to make those the same base number. Okay? Pause. And unpause. 2 and 8. We've got as the same base. Okay? 2 can't change base. He is 2 to the 5x power. There's nothing that can change there. But 8 is the same thing as 2 to the 3rd power. Right? Like 8 is 2 to the 3rd. But then it's also got the 5 there. So this is actually, when there's a 3 and a 5, this is actually 2 to the 15th power, because I multiply those together. Okay, so 8 became 2 to the 3rd, then to the 5th, that's 2 to the 15th power. And now that they're the same base, I can cancel them off. So this is like saying 5x equals 15, and then divide by 5, and x is 3. So that's kind of nice. That was kind of fancy. Okay. 28, I can make them the same base as well. You could make 9 3s to the 2nd power and then make him to the x power. But actually, 81, I can write in terms of 9. So I can just leave this as 9 to the x power, if that makes any sense, right? You don't have to convert this to a 3. 81 is like 9 squared, except I want 1 over 81. Right? 1 over 81 is to the negative 2nd power. If I want it to be a fraction, I make it a negative exponent. We talked about that yesterday, okay? So now, since they're both bases of 9, we can cancel off. So x equals negative 2. I didn't even have to do any algebra. That was exciting, okay? And that's how that works, all right? Now, these last two, I have 29 and 30. And what we try to do is we try to get those to be the same base. But 5 and 7, I cannot make those that be the same base. So what I do is I can either put an ln in front of both, or I can put a log in front of both. And it doesn't matter, except for number 30, you're going to want to use ln, right? Because ln and e cancel, okay? So if you haven't paused, pause, do those. And I'm going to go through 29 right now. I am going to, instead of doing ln, let's do log. I don't care. It doesn't matter. Log 5 and log 7, okay? Now, the reason why I put a log in front of both is so I can move this 2x down in front. So I've got 2x times log 5 equals log 7, okay? And then what I want to do is I'm going to divide by log 5 and divide by log 5. And I have 2x equals, okay, let's see if I have the right thing on my phone to be able to do that. Okay, I think I do. 7 log divided by 5. Okay, I think I get 1.2091 if you, whatever. And then if I divide by 2, somebody make note of that. If you did not get the same thing that I did, please put a star by this and bring it to my attention tomorrow, because I do not quite trust my phone calculator. This looks like a reasonable answer when I get 1.209, because what this is asking for is, it's saying 5 to what power gives me 7 is what this is saying, right? And 5 to the first power gives me 5, and 5 to the second power is 25. So it might be right, 1.20191. I bet you that's right. So overall final answer, 0.6045. Cool. Okay, now 30. I like these ones better because these are ln's, and ln and e cancel. So all I have to do is 3x equals ln of 4. Whoop, ln of 4. And then I'm going to take whatever that decimal number is, and I'm going to divide by 3. So let's see. I do have an ln. 4 ln divided by 3. That one was nice. I bet you this one is right. 4621 is what it would be, rounded to 4 decimal places. Okay, so there is that. 31 and 32 are going to be like solving the how long right here. I see how long. That means we're solving for t. T is what we don't know, and that's going to like be unwinding the equation. And half-life, the formula for half-life. We will write these all down on a note card tomorrow. A equals P times 0.5 to the, yesterday I told you wrong, I'm sorry, but I corrected myself at the end. It is T over K power, or whatever they called it. T over H, or whatever they call half-life. Either H or K, whatever you want to call it, or whatever variable you want to use. The half-life of radium is 1590 years. That goes in right here, half-life. How long? T is what we're solving for. Will it take for 10 grams to decay to 1 gram? 10 grams is my P, 1 gram is my after amount. Okay, so let me write this all down. 1 equals 10 times 0.5 to the T over 1590. Okay, I've had kids before that are tempted to multiply these together, but the 10 doesn't have an exponent up here, and this one does, so I cannot do that. Okay, that's a T. So I have to divide by 10 to begin with. Okay, to get him to go away. 1 divided by 10 is 0.1. 1/10, right? 0.5 to the T over 1590. Okay, then what I can do is I can either log or ln both sides. It doesn't matter which one you use. Let's do ln. I don't care, whichever one. Okay, so that allows me to move this junk in front. So I've got ln of 0.1 equals T over 5730 times ln of 0.5. Okay, and then I'm going to divide the whole thing by ln of 0.5 and divide by ln 0.5. And so I get a big long decimal number is equal to T over 5730. Let's see what I get for my calculator. I'm doing this on my phone, so we don't really know. I've got ln of 0.1 divided by ln of 0.5. And I get like 3, whoop, come on. Oh, I hated this thing. I inserted this as a picture and it just hates me. Nah. Okay. I get something like 3.3219 or something. Okay, I'm going to multiply by 5730 and multiply by 5730. So T equals times 5730. Why 5730? I'm totally making numbers up now. What? Are you yelling at the computer yet? Or at the TV? 5730 is the half-life of carbon-14. I just threw that in there. That is not the right number. This is 1590. I am totally making numbers up now. 1590, 1590. Are you totally yelling at me yet? Meh. Okay, start again. 3.3219 times 1590 is 5,281, let's go 82 years-ish. My rounding might be off now because I didn't use this full decimal. But that's what I get for time, okay? If I am starting with 10 grams and I am decaying until I get to 1 gram, 10 grams and split in half would be 5. 5 split in half would be 2.5. 2.5 split in half would be 1.25. So I have split in half 3 times and then a little bit more. 3 times and 0.3219 times, to be exact. That's what this number stands for. This is how many times I have split in half. Okay, that's reflected by this thing. And then I take that number and I multiply by 1590 and get my time. How long? Yeah, that's all we're looking for. How long? That many years. This thing has been producing radium or whatever. Radium has been splitting in half. Okay? All right, 32. What annual interest rate should you invest your money if you want to double it in 6 years? Annual interest rate. If you want to double it. Annual interest rate. I don't think we're using PERT because it doesn't say continuous compounding. Annual interest rate. Oh, maybe we are though, because your interest rate is annual. So maybe we are using PERT. We'll just say we're using PERT. I'll make sure on the test I'm more clear about which formula you're going to use. So like I will say continuous compounding. So let's use PERT. PE to the RT power. You're trying to find your interest rate, so that's R. Time is 6, and we want it to double. Okay, so here's kind of like where you get to kind of choose what P and A are. It's just as long as it will end up being double. So I could choose that my initial P is 10, maybe $10 or $100. Let's say it's $100 to begin with. My after amount would be $200. It doesn't matter what you choose because the first thing you're going to do is divide that over, and you're going to end up with 2 equals e to the 6r, right? It doesn't matter what you end up with. In fact, if you can remember that, you can just go straight to this step because you're going to divide it and it's going to go away. Now I'm going to ln both sides, and ln and e are going to cancel. So I've got ln2 equals 6r, and I just have to divide by 6, and that will tell me what my interest rate is. All right. ln2 divided by 6. My interest rate is 0.1155, so that's 11.55% for an interest rate, which seems a little high, but, you know, well, doubling in 6 years, it's got to be a little high if you want it to double in 6 years, okay? So there's that. I'll try to make that a little bit more clear that we're using continuous compounding because that's what PERT is. Okay, 33. We did this the other day, but you need to follow the steps and go into your calculator and make you an exponential model. This is your X and this is your Y. So here's your steps. You can, it doesn't even want it to be graphed, so you don't necessarily have to turn your stat plot on. But if you want to look at the graph and see if it's exponential, you would have to go to second Y equals and turn your stat plot on. And then you could graph this stuff if you want to, but to get your data in there, you go stat, the stat button, and you hit enter, which is edit. It's like already on edit. Okay, and then you list, in your list 1, you're going to be putting these X's, so 0 through 45. In list 2, you're doing your Y's, which is these numbers, okay? If you want to graph it, you'll need to change your window, so your X's will need to go from like 0 to maybe 50. Your Y's, your smallest Y is 5, so go from 0 to like 30 on your Y's, and then you can graph it, and it should be like, I don't know. No, it's exponential, but it's going to be an exponential decay because it's starting up high. So it's going to go something like this. Possibly like that, a decay function. Okay? And then to get an exponential model after you've entered your data in there, you're going to hit the stat button again, but you're going to go over to calc, and then you're going to go down to EXPREG, and it's going to spit out a function. Oh, and you hit enter, enter, enter. It's going to ask you for a bunch of settings, and then it should spit out a function that says like y equals a times b to the x power or something like that. And it will tell you what a and b are, and that's what you need for part A here. And then according to this model, what will the wind chill factor for a 23 mile per hour wind? That means you're going to plug that in for your wind speed, which is your x coordinate. So you're just going to take 23 and you're going to plug 23 in here, and you're going to figure out what y is for part B, okay? But when I'm back tomorrow, I'll check that with you because I will have a decent calculator at that point, Okay, so that was kind of long. Maybe that was a long video. I don't know. But there you go. Okay, tomorrow we'll fill out a note card. We'll go over any questions on the last section. What was it, 3-6? And we'll do that last problem if you need help on this number 33. Okay, there you go.